Push that rock here with Simpson math. Let's talk about radicals for a minute. So we're all familiar with the number line. If we have a number line, it starts at 0, we decide that this is 1 unit, and we add a unit to the first unit. Let's get a highlighter out for a minute. If I add, here's 1 unit. If I add that same distance in, we call that number 2. If I add that same distance in again, we call that number 3. So 1 plus 1 plus 1 equals 3. We've decided to call 3 ones the number 3. So what I want to talk about when we introduce this idea of radicals is, what do we call a number that is equal to this distance right here? What do we call that? Okay, this is clearly a distance. If I were to lay this distance down onto my, let's make it red. So here's my red distance right there. If I were to lay that down, it would come out to be about right there. Okay, if I just lay that down, what is that distance right there? What is this distance right there? That's what we want to talk about. And the one thing we know from the ancient Greeks is that if you have a right angle here, one leg squared plus the other leg squared equals this long distance here called the hypotenuse squared. We all remember that. It's the leg squared plus the leg squared, the other leg squared, is equal to the hypotenuse squared. You may have seen it like this: a squared plus b squared equals c squared, where c is the hypotenuse, b is one leg, and a is the other leg, okay? So in this case, our legs are both 1. So I put in 1. And that's going to be equal to c squared, or this distance squared. Okay? Well, 1 squared is just 1. 1 times 1 is 1. So I have a 1 here, I have a 1 here, I add that up. I have 2 is equal to c squared. What do we call that? What is this? What number times itself will give me 2? Let's think about that for a minute. I have some notes over here. Let's look at them. 1.4 times 1.4, well, that's almost 2. It's 1.96. So it's not 1.4. It's close to 1.4, but it's not 1.4 because 1.4 times itself doesn't give us 2. Okay? What about 1.5? 1.5 times 1.5 is too big. It gives me 2.25, so it's a little too big. Okay, what about 1.41? If I multiply 1.41 by itself, I get something really close to 2. I get 1.9881. Not quite 2. How about 1.414 times itself? 1.414 times itself. Well, that gives you 1.999396. Almost 2, but not quite. It turns out that there is no decimal number that you can multiply by itself and get 2. Now, when I say there's no decimal number, I mean there's no decimal number that I can write down that terminates somewhere, ends, or repeats. I would have to write forever a different sequence of numbers. It would start with 1.414 and it would keep going. So that's very unwieldy. So we need a name for the number that you multiply by itself to get 2. We just call it the square root of 2. And in modern mathematics, the symbol that we use is, we take the square root of both sides and we get c is equal to the square root of 2. Now, when you take the square root of both sides of an equation, you need to sometimes think about the plus or the minus, because a negative number times itself can also give you a positive. But in this case, we're just talking about a positive distance, so I'm going to refer to it as the square root of 2. And in modern mathematics, that's what we call this distance here, the square root of 2. It's a distance. It's a weird-looking symbol. Yes, it's weird to deal with, but it's a number like any other number. Well, maybe not like every other number. We call numbers like 2 and 3 rational numbers, and this is a irrational number because you cannot write it as a ratio of integers like you can other numbers. So this is an irrational number, but it's a real number, and it's this distance. Now, what happens if I wanted to take this distance and put it on itself? When I did 1 and added it to itself, I got 2. So what if I want to take this distance and put it on itself? so that I'm over here. So I get something like that. So I've taken the square root of 2 and I've put another square root of 2 on it. What do we call that number? Well, we can't call it the square root of 4. We can't add 2 and 2 and say there's a 4 under there because the square root of 4 is 2. It's clearly not 2. Okay, so you can't add these up. All you can do is say, well, there's a square root of 2 here, a square root of 2 here, so I have 2 square roots of 2. And that's how you add radicals. They must be alike. If I take the square root of 2, try to add to the square root of 3, I just have square root of 2 plus square root of 3. I can't add them up. But if they're alike, well, then you can say you have 2 of them. So if I were to have, let me get another color here, the square root of 2 plus the square root of 2 plus the square root of 2 3 times, well, that would be 3 square roots of 2. Okay, now you can multiply and divide these radicals. So if I need to take a number like the square root of 2 times the square root of 3, that's okay. I can call that the square root of 6. Or if I have the square root of 8 divided by the square root of, say, 2, well, then that is the square root of 4, which would be 2. So you can multiply and divide radicals, but you can only add them if they're alike, and you add them up like terms. Sort of like this was an x plus an x, you'd get 2x. Math made simple. Simple math.